Hey everybody, I wanted to do a quick video here on the nitrogen rule. Sometimes this is referred to as the odd-even rule when you're dealing with mass spectroscopy. So this video suggestion actually came from a comment in one of my other videos involving mass spec. So if you ever have requests, I am certainly willing to look at them, and if I have the time I can make a brief video on it. And we also do offer private one-on-one mentoring over on our website. You can find the link to that in the description. So if you ever had a lot of detailed questions you needed answered, just go ahead and get in touch with us that way. So the nitrogen rule, or the odd-even mass rule, is something that applies to organic compounds. And it's important that you keep in mind this is in the context only of organic compounds. So when we start to get into inorganic compounds, this rule no longer holds any type of weight. It applies to compounds that contain only hydrogen, carbon, nitrogen, oxygen, and the halides. Now that can also include sulfur and silicon and a couple other ones that you tend not to find nearly as often in organic compounds as you do these here. But in general, again, if it's something that you would find in a normal organic compound, this rule will apply here. And it also only applies to neutral structures. So you cannot have organic structures that have a charge associated with them. The valence rules should all be met, and you should not have any type of formal charge on the structure when you're dealing with this. And a lot of these sort of subset rules come from the fact that nitrogen creates 3 bonds when it's in its normal valency. And then if you added one additional bond, it's going to break that valency and it would have 4 bonds. And so that's going to change your odd-even ratios when you're doing things like that. So what is the actual nitrogen rule when we take a look at it? So it states that an odd mass is going to mean an odd number of nitrogens, and an even mass is going to mean an even number of nitrogens. Again, in the context of an organic compound that is neutral. So a lot of times instructors will bring this up when they get into mass spec because it is a very handy rule to know when you're looking at a mass spec. If you have an even or an odd mass number, and when I'm talking about that, we're referring to the M plus peak. So if you don't know what I'm talking about there, we have another video distinguishing the M plus peak and the base peak for mass spec, so you can check that out as well. So if you have an odd mass number, you have an odd number of nitrogens, and if you have an even mass number, you're going to have an even number of nitrogens. Now, something that is very important to note here is that when it says an even number of nitrogens, that can include 0. So it could be 0, 2, 4, and so on. Because we could certainly have an even mass, and it means that there's no nitrogens at all. In fact, that's probably very common, where you could have just carbon, hydrogen, oxygen, or just hydrocarbons or things of that nature. So don't get confused and suddenly think every organic compound must contain nitrogens. It is simply that it could often fall in 0 when you've got that even value there. All right. Now, to give you a couple of brief examples here, if we were to look at the structure of TNT, which is trinitrotoluene, it would be C7H5N3O6. And when you add all of this up, it's going to come out to 227 as the molar mass. So if you were looking at the M over Z, right, this would be the M plus peak. This would be the grams per mole approximately, rounding. So 227, because this is odd, that means we should have an odd number of nitrogens. And sure enough, the nitrogens are equal to 3 in this case. So we do have an odd number of nitrogens when we have that 7 appearing there. To give you another example, if we were to take a look at caffeine, the molecular formula for caffeine is C8H10N4. So just based on that alone, you should be able to come up with a even or an odd. And in this case, because N is 4, we would expect that it's an even number. And that is the case. It's 194. and that would be the value associated with caffeine. So because we end in a 4, okay, that's an even number. We have an even number of nitrogens. Another, maybe a simpler example here, let's just say we had ethylamine, so CH3, CH2, NH2. In a case like this, you're going to have 1 nitrogen, so we would expect an odd value, and if you add all of this up, it turns out to come to 45 as the mass value expected here. So you can see the odd-even rule playing into effect here every time we've got organic compounds with the proper makeup of atoms. The odd-even rule for nitrogen is being applied here. Now, how quickly can we violate this rule if we go outside the realm of organic? Well, very simple. You just take NO or NO2. Now both of these have 1 individual nitrogen, so we would expect odd because 1 is an odd number. However, when you add this up, this would be nitrogen is 14, oxygen is 16, so that's 30. And then when you add another 16, you get 46 due to that oxygen. Both of these have even masses, and then right here, you see you only have odd valued nitrogens at 1 apiece. So because this is not considered an organic compound, this would be inorganic, it's already violating the rule even with the simplest of structures. Okay, so there's plenty of other examples you could go through. I encourage you to pick out a couple of organic examples that have nitrogen and prove to yourself that this works by looking up their mass in exchange. Now, again, as I mentioned earlier, this is commonly applied to mass spectroscopy. And that's because when you're looking at mass spectroscopy, if you only have your mass spec and you are not given an actual formula to work with, it can help identify nitrogens and whether you have an even or odd number, right? So here's an example. Pyridine, this is the mass spec for pyridine. Before I even draw pyridine here, I can go over and I can look at the M plus peak, and that one happens to be this value right here. And this number comes out to 79. So based on that, pyridine should have an odd number of nitrogens. And sure enough, if I draw out pyridine, it would be a structure that has 1 nitrogen in the aromatic system, like this. That's my pyridine, right? That is going to be 1 nitrogen, and therefore we have an odd mass associated with it. So, if I come down and I take a look at another, this is for triethylamine, and when I take a look at this one, the mass here is showing up at 101. So the same principle applies with the odd. Because we're at 101, we would expect an odd number of nitrogens. And when I take triethylamine, it's going to be an ethyl group 3 times. So I'm just going to write that this way instead of drawing all of them out. And then you would also have a nitrogen, a single nitrogen. Okay. So that again, because we only have 1 nitrogen, that's odd. 101 is an odd number. This rule is holding true as we're going through and we're looking at the mass spec. So hopefully this helps tie everything together and you now understand the nitrogen rule, again sometimes called the even-odd mass rule. So just in review, it only applies to organic compounds. It applies to compounds containing only hydrogen, carbon, nitrogen, oxygen, and halides. That's a little bit redundant because that's primarily what organic compounds contain. However, let's say you find the odd organic compound that contains a metal or something like that embedded into the structure. Then in that case, you would no longer be holding this rule because you could have other violations. Right? And then it only applies to neutral structures. So essentially, make sure you don't have anything with formal charges and make sure you're staying away from inorganic compounds or very bizarre organic ones that would have atoms we wouldn't expect. And this rule can hold steady. It's very useful in helping you solve mass spec, especially without a formula. So that pretty much covers everything we want to talk about. As always, please remember to like the video if you found it helpful. If you subscribe, you'll be up to date with all of the latest information that we release. And as you can see, I try to interact with comments and users as they come to me. I can't always promise I'll have time for stuff like this, but this was content that was simple enough to address in a case like that. Also, check out our website. The link is in the description. We are now live. We are taking mentors, one-on-one tutoring, and we also are selling our guides over there, which are very, very detailed guides. I have one on spectroscopy. We have had people buying the guides, and we have also had people reach out to us for mentoring, so it is fantastic that you guys are continuing to support the channel through those other means. Thank you very much, and I will see everybody for the next video.